Section 4.2, Relative Extrema. All right, so what we're going to do is we're going to look at what we call extrema or max or mins. Now, we call them relative extrema, relative max, relative min. Sometimes I'll say local max, local min. Same thing as relative max and min. All right, right here on the graph, we have a local or relative max. Okay, it's a maximum relative to this area. Right here, we have a relative or a local minimum of this graph. Right here, local max. Right here, local min or relative max, relative min. And here, a relative max, okay? Now, notice about these points where we have the max and mins and so forth. Notice your tangent line. What is the slope of the tangent line at that relative max? It's 0. What is the slope of the tangent line at this relative min? It's 0. Slope of the tangent line here is 0. Slope of the tangent line here is 0. And the slope of the tangent line is undefined. So I'm going to say f prime is undefined. Okay, so notice where we have these relative max and relative min values. Either where f prime is 0, or my slope of my tangent line is 0, or f prime is undefined, okay? Now, what do they mean by max or relative max? They mean that what? At some point the graph is going up, and then, or just to the left of that point, the graph is going up, and then just to the right of it is going down, and so forth. That's what these paragraphs are about in the notes. All right, now, they also talk about a critical point and stationary points, okay? They say we define a critical point for a function f to be a point in the domain of f at which either the graph of f has a horizontal tangent line or f is not differentiable. So the points of the graph where we have a horizontal tangent line or f is not differentiable is called a critical point, okay? Then it goes on to say x is called a stationary point of f if f prime of x is equal to 0. What does that mean? That means that this point, this point, this point, and this point are all stationary points as well as critical points. Now, this point is not a stationary point. All of these are critical points here, okay? All these ones that I pointed to a minute ago. But this one's a critical point and not a stationary point, because the stationary points only those values where my derivative is equal to 0. All right, so what do we care about critical points and so forth? Well, a function f has a relative extrema at these critical points where f prime changes signs. What does that mean? Well, right here we have a critical point. Notice that f prime changes signs. My slope of my tangent line is positive, then all of a sudden it's negative. Or right here, f prime changes signs. My slope of my tangent line is negative, then it changes to positive. Same thing over here. Slopes of the tangent line are positive, then they change to negative. So we're going to have relative extrema where f prime changes signs. All right, so basically it's like we looked at in the last section, but now we're saying a relative max, relative min, and so forth, instead of just increasing and decreasing. All right, then your book goes over the first derivative test, and I'm just going to show you that. You can read through it on your notes, but I'm going to show you that in just a minute. All right, let's look at critical points. Let's look at critical points in our first example from section 4.2. We have a part A. And part A says, find all the critical points of f of x is equal to the cube root of x squared minus 16. Well, let's do a rewrite. Let's say f of x is equal to x squared minus 16 to the 1/3, okay? Now, to find the critical points, what am I doing? I'm finding where the derivative is, or where the tangent line has a slope that is 0, or I can say where the derivative is equal to 0, and where the derivative is undefined. So let's find my derivative, f prime of x. That'll be 1/3 times x squared minus 16 to the negative 2/3 times the derivative of the inside, which is 2x. Remember, that's a chain rule. Well, let's clean this up. I could call this 1 over x squared minus 16 to the positive 2/3 times 2x. Then I could say this is 2x multiplied by that 1 up top, or 2x over x squared minus 16 to the 2/3, and that is what f prime of x is equal to. Now, what do we want to do? We want to find where my derivative is equal to 0 and where it's undefined. So let's find out where this derivative is equal to 0. So let's take this derivative, set it equal to 0. 2x over x squared minus 16 to the 2/3, we're going to set equal to 0 and solve. So if we multiply both sides by my least common denominator, I get 2x. I get 2x is equal to 0, or x is equal to 0. Let's find out where my derivative function here is undefined. Well, it'll be undefined when my denominator is equal to 0. So set this denominator, x squared minus 16, x squared minus 16 to the 2/3 is equal to 0. Well, raise both sides to the 3/2 exponent, and you get x squared minus 16 is equal to 0. Or you get x squared is equal to 16, and x is equal to plus or minus 4. All right, let's see. Go back to your notes. Look at what it says for a critical point. If you go back to your notes, it talks about what? We define a critical point for a function f to be a point in the domain of f, in which either the graph of f has a horizontal tangent line or f is not differentiable. So I need to make sure that all three of these x values are in my domain of f. Well, actually they all are, right? Look at your domain of f. What will your domain of f be if you have a cube root? It'll be all real numbers, right? So what did it ask me to do? Find all critical points. So critical points will be x is equal to 0, x is equal to -4, and x is equal to +4. All right, part B. Which of the answers from part A are also stationary points? What are the stationary points? The critical points that you found by letting your derivative equal to 0. The critical points you found by letting your derivative equal to 0. What was the critical point I found by letting f of x be 0? X is equal to 0 is also a stationary point. X is equal to 0 is also a stationary point. All right, next we're going to go on to that first derivative test we talked about earlier. Instead of reading all that, basically what you're doing is you're testing to see, okay, where's it increasing, where's it decreasing? If it goes from increasing and decreasing, you have a relative max. If your function goes from decreasing to increasing, you have a relative min. All right, so let's see. If we look at our notes, we have an example, and it says, find the relative extrema of f. List the answers in ordered pair. So we have f of x is equal to 2x plus 13x to the 2 over 13, okay? And it wants me to find the relative extrema and list the answers in order pair. All right, so to find the relative extrema here, I'm going to do that first derivative test, okay? And what I do for my first derivative test is I find those critical points first. Then I draw me a number line, like we did in the last section, with f prime, break it up with those critical points, and run test values. Well, let's do so. Let's take our first derivative, f prime of x. F prime of x will be 2 plus 2x to the what? Negative 11 over 13. Okay, verify that for yourself. All right, so now let me do a rewrite here. Say this is 2 plus 2 over x to the positive 11 over 13. In other words, if I bring that to the denominator, it'll make it positive. All right, so let's take this derivative, find out where it's equal to 0. So 2 plus 2 over x to the 11 over 13. Find out where that's equal to 0. And we'll find out where it's undefined as well. Where is this derivative function going to be undefined? Whenever my denominator, x to the 11 over 13, where my denominator is equal to 0. So now we'll just solve each one of those. So to solve here, I could multiply both sides or each term here by my least common denominator. That gives me 2 times x to the 11 over 13 plus 2 is equal to 0. Or 2x to the 11 over 13 is equal to negative 2. Or x to the 11 over 13 is equal to negative 1. All right, now what do? We raise both sides to this reciprocal exponent. So I have x to the 11 over 13, and I'm going to raise that to the 13 over 11. Well, I need to take negative 1 and raise that to the exponent of 13 over 11 as well. So this becomes x to the first, or just x, is equal to, now think about what this is. This is really saying the same thing as negative 1, take the 11th root and raise that to the 13th. Because remember, this denominator here is going to be your index, the numerator is going to be your exponent. Well, what is that going to be? What's the 11th root of negative 1? Negative 1. What's negative 1 to the 13th? Still a negative 1. All right, let's solve this equation. Let's raise both sides to the reciprocal exponent. So the reciprocal exponent of 11 over 13 is 13 over 11. Let's raise 0 to the 13 over 11. Well, that's x to the first is equal to, remember how we rewrite this? We rewrite this as 0 under this radical. 11 is going to be my index, and my exponent is going to be 13. So what's the 11th root of 0? 0 to the 13th is still 0, right? All right, so what do we have here? We have critical points of negative 1 and 0. That new fancy word, critical points. We've been using these. We just didn't call them critical points in the last section. All right, let's break up my number line. Here's 0. Here's negative 1. And let's run some test values, okay? So we're going to run some test values. I'm going to use my derivative function here. F prime of x here. And let me run some test values through here. Let's pick a value over here, maybe like negative 2. What happens if I input a negative 2? Well, this part is positive 2 plus 2 over negative 2 to the 11 over 13. Okay? So if I take the 13th root of negative 2 and I raise that to the 11th, that's still going to be some kind of negative, isn't it? Sure will be. It'll be a number about, some small number, 1 point something, okay? And if I divide that by 2, if I take 2, divide by a number that's less than 2, but still 1 point something, I get a negative number that is less than 2. What's 2 plus a negative number that's less than 2? What kind of sign is that? Okay, 2 plus a negative number that's less than 2. Wouldn't that be a positive? So I would put a positive right there. Remember, we're only worried about the sign here. Now, I'm going to show y'all a better way to check this, or a quicker way, basically in your calculator, on another video, okay? All right, but anyway, let's continue with this problem. Let's pick a value here like -1/2, okay? So if I pick -1/2 and I plug it into this derivative function, I get 2 plus 2 to the -1, or -1/2 to the 11/13, okay? Okay, let's see what I get here. All right, if I take the 13th root of a negative and raise that to the 11th exponent, I'll get a negative number, and a positive over a negative is negative. So I'll have 2 plus some negative number, right? Now if I take a 1/2 and I raise it, or I take the 13th root, raise it to the 11th, I get a number that is going to be a negative, but it's going to be some decimal number, like negative point something, you know? So what happens if I take 2 and divide by a number that is less than 1? That gets bigger. That makes 2 larger. So I'm going to put larger than 2. What's 2 plus a negative number that's larger than 2? Well, that's going to give me a negative. Or you could just plug all that into your calculator and calculate it, see what it gives you. All right, so let's do the same thing. Like, let's pick 1 over there. So we basically have 2 plus 2 if we pick 1, and we get a positive here, okay? So what does that mean as far as f? And remember, this is f prime. What does that mean as far as f if f prime is positive? That means f is increasing. If f prime is negative, that means f is decreasing. And if prime is positive, that means f is increasing again. So think about this for a second. What happens here with my function? If it goes from increasing to decreasing, I'm going to have a what up here? A relative max, right? So I have a relative max. Let me see how we said to list it. List your answers in ordered pair here. Relative max at the point what? -1. Well, what's the y coordinate there? Take that -1 and run it through my original function to find a y coordinate, okay? So we have f at -1 is equal to 2 times -1 plus 13 times -1 to the 2/13. Well, this one's easy. That gives me -2 there. What about this one? What's the 13th root of -1? -1? -1 squared is what? 1. 1 times 13 is what? 13. So what does that give me? 11. So I have a relative max at the point -1, 11. What about when my function f goes from decreasing to increasing? I'm going to have a relative what there? Relative min. So relative min at the point 0, comma what? Take the 0 and plug it into your original function. And what do you get out? 0. There's my relative max, relative min, and they told me to list it as an ordered pair. There we go.